Using function notation in graphs. You will find this on page 263 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. Using function notation in graphs, it's almost like we're going to combine functions, the way of writing functions and graphs. So let's look at the example. The graph of this and this, so it's two different graphs. This curve one is called fx and this straight line is called gx. Are drawn in the grid below. The line y equals gx is the tangent to the curve at the point 0.75. Now find f 1.5. So this is just straightforward functions. So but now you don't have an equation to substitute it in. So you have to make use of your graph. Oh, can I just make it bigger for you? Okay. So if I'm going to say find f, it's like the value of x is 1.5. So go to 1.5, draw up, and it's f. This is the graph f. Until you touch the graph f, draw down or draw it to the y-axis and horizontal, and y equals 1.2. G negative 0.5. So go to negative. Now you draw until you touch the G graph, draw, and then you read it down. And that will be 0.4. And then G minus 1. Now this is the inverse. Can you remember? Inverse, the x becomes y and the y becomes x. So this is actually not saying x equals, it's actually saying the opposite. Y equals negative 0.5. So you go to y at negative 0.5 and you draw until you touch the g x graph and then you draw up. So remember, it's the opposite. Okay, the inverse. And then you read down, and if you read down here, let's just move it up a little bit. So the inverse function, the value is swapped, so from, and it's negative 1.3. Okay, let's just see. It was there till it cuts, and there, negative 1.3. Okay, and then find the range of values of x such that fx bigger than g. Now it's always like this. The graph that's on top will be the biggest one. Now if you look at this, you will see, okay, which one is on top here? It's f, okay? So then look, there g goes on top, until, no, it stays on top. So if they say where fx is bigger, okay, so where is fx? It's actually just that little part. Okay, so the graph that is on top is the bigger than for that range on the fx mark. So where x is smaller, it's from there, than negative 1.6. So from there on, it will not only up to there, to continue to infinity, it will stay bigger. This one will stay below, smaller. Okay, solve fx equals 0. So now it means y equals 0, and that's always on the x-axis. If you just read down, and okay, so we can start, doesn't matter which side, we can start here. It seems to me I start there. So it's negative 1.75, then it's 0, and then it is 1.75. It's just reading where this fx is cutting the x-axis. That's where y equal to 0. Find the radius of value of for k where fx has 3 solutions. Now it will have 3 solutions under the turning point. So I count 1, 2, 3. I'm just going to take a sharper point. Yeah. Okay, so if I draw a line here, 1, 2, 3. Here, 1, 2, 3. But on the turning point, only 1, 2. On the turning, 1, 2. But between this 2 and negative 2, it will cut 3 times. And this is what I'm showing you there. So where k is bigger than negative 2, up, and smaller than 2. Not equal signs, because equal signs only 2 times. And then the last one, solve. Now if they ask you something like this, just rearrange it. Because this is negative, take it over. Okay, so this is fx is equal to 1. So you go to 1, you draw a line where it touches down, touch, down, touch, down. And then you start just reading that values. Negative 1.9, let's see this one, 0.3, this one, 1.55. As easy as that. Let's do an example. Okay. I want you to stop the video and I want you to do try now 26. Okay, you can continue the video as soon as you are finished. Okay, let's start. This is just almost going to be reading from the graph, maybe the final part, it's on the graph. Okay, so number, try now. This is going to be number A, and this is the first one. The graph of this are shown above. Again, G straight line, it's not always like that, it's just a coincidence. Fx curve, but it's more often than not often. Okay, find the value of f negative 2. So go to negative 2, let's just take a line. Go to x value negative 2, there, and go to the f graph. Okay, this is my f graph. So there, and where it touch, I'm just drawing it towards my y-axis, and that will be negative. Now this is 10, so it's actually 1, 2, 3, 4, 5. So negative 15. So y is equal to negative 15. Okay, that was the first one. Then the second one, G is 0, so go at 0, but now you must remember, you must draw to your G graph. That's the straight line. Then the ruler. Okay, it upper, and it's touching there. And it looks like, okay, this is 15, 16, 17. I'm going to make bigger that you see better. So if you look at this, it's going to be 15, 16, 17, 18.5. So y equals 18.5. Okay, so it's between 18 and 19. Okay, then the next one. Use your graph to solve the equation fx equals 20. Now it's saying that the value of y will be 20. So go to y, to the y-axis at 20. There is 20. And you must draw to the f. So from 20 to the f, where it cuts, you just go down. And if you read from there, y equals 20. So let's just see fx. I just want to make it a bit smaller. Okay, so if I say y is equal to 20, I go to f, and I'm just reading it down here. And it's going to be x, okay, let's just see, I see, something was not looking right. Now I see why. I forgot to take it to this side also. So there's two values because it's cutting 2 times. So don't draw it through and see f how many times. So if I look at that, I just want to go back to the question, that is number B. And it's the first one. And then it will be x is equal, and let's just negative 4 point, it looks like negative 4.3. I'll make it again bigger that you can see better. Because here, okay. Okay, so it looks like negative 4.123. negative 4.3 or x equals, it looks like 1.4, 1.5. This looks like 1.5. Okay, and then I go on. The equation, it's where they are equal. Now, where is the two graphs cutting? I'm just going to clean a little bit here. And you can also do that. Do it with a pencil or something like that. If you see it's too many lines, just clean. Okay, because it's on the graph now. So it cuts at two places. It's cutting here. And it's cutting here. Okay, the line's a bit thick, so it influenced my accuracy. So in this case, it's the second one. Okay, and that will be where x is equal to, okay, let's just see. It's going to be negative 4.4. Okay, or it's going to be x is equal to, it looks like 1.4. Okay, and then the next one, where fx is smaller than, so where gx is actually bigger. Now, where is gx bigger? Gx is bigger from there to there, where it cuts. Okay, so actually it's going to be that range. So this is actually very nice because I can use the previous answer. So it's where x is bigger, and because they say not equal, so I don't put the equal sign. Negative 4.4 and 1.4. Okay, and then the last one, number C, or almost last. Use the, okay, let's just see. I just want to move it a little bit up. Use the points A and B to find the gradient of this as an exact, find the gradient of y equals gx as an exact fraction. Okay. A and B. So where is A and B? Okay, there we have A and B, and they want me just to find the gradient. Okay, so what is A? It's almost like I think it's going to be more difficult. So A was negative 5, and then negative 5 and 40. And what is B going to be? It's going to be 2 and 10. Okay, so, and now I'm just going to find the gradient. So it's y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. And that's going to be 10 minus 40, and x2, 2 minus negative 5. So it's minus 30, and this is going to be 7. And if they want it as exact, so just simplify this. You can leave it like this, or negative 4 and 2 over 7. Don't make it a decimal. And then draw the tangent to the graph at negative 3, that point. So negative 3, here's negative 3, and negative 27. Okay, there's negative 3. Negative 3 and 27, but it's just going to be where it cuts here. Okay, so in this case, if I look here, oh, it's on the turning point. Can you see that? So it's actually just that point. And I know that the turning point is a horizontal line. So let's just make it smaller again. So draw the graph, write down the equation of this tangent. Okay, so I draw it, did you see? And then the equation of that tangent, it's going to there at 27. It's cutting the y-axis, and it's cutting the y-axis where? At negative 27. And that is the final answer.